The industry is stuck in what we're calling the downstream trap. We're talking about multi-million-dollar security stacks that are completely failing right now simply because they're looking in the absolute wrong place. Your security team is building better walls, sure, but they're still leaving the master keys sitting right inside the room. Let's look at the data, because it paints a really urgent picture.
Take a look at this massive gap. Analysts at Identiverse 2026 found that a staggering 57% of enterprise identities are literally invisible to standard security tools. 57%. And attackers? They are actively exploiting this blind spot. Because when an AI agent gets tricked, all those fancy standard locks on your network just don't matter. The attacker leverages those invisible identities to use what are basically master keys directly against your organization.
This core structural flaw is perfectly summed up by GitGuardian. They pointed out that static, long-lived credentials are the attack surface that agents inherit and amplify. Really think about that for a second. Our current tools are only watching real, full-power credentials after they've already been issued to the AI agents. It means we're reacting to the blast radius instead of preventing the actual explosion.
So, to understand the fix here, we have to compare the two approaches. Downstream security, which is our current trap, means you're watching a real, full-power credential post-issuance. It just assumes the master key is already out there in the wild. Upstream security, on the flip side, changes what the key actually looks like before it's ever handed to the agent. So we really have to stop just building better walls and actually start fixing the keys themselves.
Section 1. Anatomy of Agentic Compromise. Let's look at what actually happens during catastrophic real-world breaches when AI agents get their hands on full-power keys. The crucial mechanism at play here is known as the confused deputy problem. It's a 38-year-old attack class, and it basically requires 3 conditions to be true all at once. Condition 1. The agent holds real, broad-scope permissions. Condition 2. It receives instructions through an unauthenticated channel, like a random document it reads. And Condition 3. The action mechanism doesn't actually verify where that instruction came from. The big takeaway here is simple. If you remove even one of these conditions, specifically what the agent holds in Condition 1, you stop the attack completely.
And hey, this is not just theoretical. In June 2026, we saw Echo Leak hit. This was a critical CVSS 9.3 zero-click prompt injection in Microsoft 365 Copilot. What happens is, a Copilot agent reads a completely normal-looking document that's secretly hiding malicious instructions. And because the agent is already holding a master key, it just obeys. 0 user clicks required. It had the key, so the injection succeeded.
We saw kind of the reverse pattern with the PocketOS breach. At minute 0, a Cursor AI agent is handed a super basic staging task. Minute 1, it hits a mismatch and starts scanning the codebase. Minute 2, it accidentally scoops up a real Railway CLI token, and literally 9 seconds later, a single GraphQL mutation wipes out their entire production database. 3 months of backups, just gone, in less time than it takes to yawn.
These are not isolated incidents. The developer toolchain has absolutely become the primary attack surface. Look at Clue. A dormant API credential from some forgotten prototype was harvested to fire off 1,000 queries in 15 minutes. At Mastra AI, a totally dead maintainer account was used to backdoor 144 packages in an hour and a half. And then with Envade, a hidden VS Code field literally handed over one-click machine control to attackers. Real, dormant credentials are just sitting out there in these execution environments, basically waiting to be found.
Section 2. Upstream to the design layer. Here is how we pivot our security strategy upstream to actually solve the root cause.
So, what exactly is the design layer? Well, it's that critical stage that determines what a credential looks like before it ever enters the agent's execution context. It's making sure the credential is a tightly scoped artifact, not just a blank check. And the best part about this, it doesn't compete with your current tools. It just shrinks the blast radius of the objects those tools are already monitoring.
Just look at the sequence of a standard security stack. You've got discovery to find credentials, governance to define the rules, and detection to watch the behavior. But notice the timing on all of those? They are all totally downstream. This proves logically that discovery, governance, and detection are fundamentally downstream of the credential's actual design. You can't just define what an agent is allowed to do, you have to change what it actually holds.
The absolutely crucial shift here is moving from impersonation to delegation. Impersonation is basically an agent recklessly borrowing a human's master key. Delegation, on the other hand, is the agent holding its own scoped, highly customized credential for one specific task. Forrester made this incredibly clear at Identiverse 2026. Delegation using scoped credentials is the only architecturally correct design pattern for AI agents.
Section 3. Containment in 2 seconds. Let's introduce Dev Fortress, the definitive upstream solution that actually enforces these critical design layer principles.
So how does this translate to real-world outcomes? Dev Fortress enforces agent scope right at the runtime layer, and incredibly importantly, it uses alias indirection for outbound API keys. What that means is the real, full-scope API key is never actually sitting in the agent's execution context. It also delivers per-agent isolated audit trails and full closed-loop automated response.
Let's walk through the exact sequential flow of how Dev Fortress achieves this closed-loop containment entirely without any human-in-the-loop latency. Step 1, an anomalous tool invocation is detected. Step 2, the agent's access is contained in under 2 seconds. And Step 3, the session's audit trail is preserved for isolated forensic review. Think about a traditional setup. By the time an analyst even sees an alert pop up, the damage is already done. This closed-loop system steps in and stops the bleeding instantly.
I want to leave you with a provocative question that should honestly shatter any remaining false sense of security you might have. If your AI agent was tricked right now, today, what master keys is it already holding in its execution context? Remember, just watching for mistakes is not enough. You have to fix the credentials. I highly recommend checking out the Dev Fortress Master Edition to lock down your design layer.